Alright, in this video we're going to take a look at attempting a repair on this VHF UHF transceiver. This one is a Yaesu FT-7800, belongs to my friend N2GJ, Jerry. And one day he said that, well, it stopped transmitting on 2 meters, but it's still transmitting on 70 centimeters on 440. So he asked me to take a look at it. So the first thing we'll do is just verify that the problem exists. So I've got this on the bench here. Power is hooked up to a 20 amp power supply over here. RF output is going in into a watt meter, a bird watt meter. Got a VHF slug in here. We'll still get a response at UHF. It won't be accurate, but at least we'll get a response, so we'll know if it's transmitting or not. Coming out of the meter, we terminate the RF signal into a 50 ohm dummy load. And this meter also has an RF sampler, so I'm taking a small piece, a small sample of that RF signal and bringing it up to channel 2 in the scope. So that's this lower trace here, so we'll be able to see the RF output here. So just one more confirmation of that. Channel 1 is also turned on. That's hooked up to a probe, and we'll use this probe to go digging inside when we start doing the debug work. But to start off with, let's verify the problem. So we'll turn the rig on. Okay, and so it's the rig coming up here, showing the supply voltage, and so right there at this channel, this one of the local repeaters here, this is a VHF channel. So if I key the microphone, we'll see that the transmitter, it says that it's transmitting with full bars there. But if I take a look at the watt meter, if I key up and let go, key up and let go, there's no deflection on the watt meter. And if I look at the scope, I don't see a signal there on the scope. So that's telling me certainly that we are not transmitting on VHF. If I tune to the next channel in the memory here, this is a 70 centimeter or 440 channel. So again, if we key the microphone, okay, we can see the transmitted power. Okay, if I take a look at this on the meter, we can see a deflection on the watt meter. Okay. And if we take a look over at the scope, I'll put the PTT in here, we can actually see that I'm getting some deflection there. So indeed, we are transmitting okay on 440, but we're not transmitting okay on 2 meters. So let's take a look at how we dig into this. Okay, so let's go dig into this. So I've taken the screws out of the case. So we can basically just lift the cover off and go take a peek inside. And what I like to do when I've got something to repair here is first just take a quick look inside to see if there's anything obvious. Any obvious problems with solder joints or things like that. And in looking through this more carefully, I really didn't discover anything obvious here. And that's okay. Sometimes you see something obvious and it's a quick and easy fix. Sometimes you don't. But one thing I can see here is there's really only one power device here. So that tells me that this radio is using this same driver or power amplifier transistor for both VHF and UHF. So, and the fact that UHF is working and VHF is not tells me that this device is probably fine, as well as the rest of the circuitry and the power amplifier, which really appears to be, this area looks to be more of the filtering for the RF output, which is going out to the connector up here. We've got the PA here. There's a larger surface mount FET here. That's probably the pre-driver or the driver for the output device. There's another larger SOT89 transistor here. So that's likely a pre-driver to kind of work our way up the stage. There's a bunch of inductors and such and capacitors in here. Looks like little switching diodes. So that's probably all of the switching stage and between VHF and UHF. And the pre-driver, driver, and RF output to go through the filter out to the output here. So, but I don't see anything obvious in anything here, just from physically looking at it. So what we do from there is let's go look at the documentation and see if that gives us any clues of where we should go looking. Okay, so the service manual kind of verifies what we learned, that the VHF signal path, transmit path, obviously has a separate VCO for VHF and UHF. But has a common pre-driver, driver, and RF output device. So that kind of confirms that. And if we look at the block diagram down here, we'll see the same thing. We zoom in here, we can see there's our separate VCO paths and things like that here. These two dashed lines coming down here are my VHF and UHF transmitted signals. We can see them coming in here. And this block diagram shows everything just kind of as blocks, but we have some switching switching diodes that are used to switch between VHF and UHF. There's some control signals called TX UHF and TX VHF that turn different diodes on and off. There's our pre-driver transistor here. There's a set of low-pass filters, one for UHF, one for the VHF path. It's a separate switching transistor here, or excuse me, switching diode here, another switching diode going up into the driver transistor, going through some more filtering and some more switches, okay, to finally getting to the RFPA. And then the RFPA, okay, also has goes out to a whole set of switched filters, okay, for the VHF path down here and the UHF path up here, ultimately out to the antenna. So there's a lot of these switches that are just shown as blocks here, which are done with diodes. Sometimes they're just ordinary switching diodes. In the case when we get down towards the higher power end, these diodes are often PIN diodes, because to get better isolation and better performance in terms of RF switching. So we certainly know that the UHF path works. So we know many of these switching diodes work, and some of these switching diodes, you know, we don't know if they work or not on the VHF path, if that's the problem. So, but we know the transistors are working and that kind of thing. So I think we can focus our area in first verifying that we have a signal coming into the amplifier chain. And if we do, we'll just follow it through the amplifier chain and see if we have it. If we look here at the beginning of the pre-driver, if we didn't have a signal there, then we'll look backwards into the VCO. If we do have a signal here, we can look forwards towards the antenna. So that's the approach that we'll take in taking a look at this. So we'll take a little bit of a look through the schematic here just briefly. I'm not going to go through this thing in great detail here, but just to kind of show you where we're looking. Down here, I've got these two switching diodes here are taking the VHF and UHF transmit paths and switching them to the input of the pre-driver transistor here, which you can see is just a common source amplifier, probably Class B or even Class C. The output of that comes up here and then goes through two paths. If we kind of zoom in a little bit further, we see one path coming up across here. That's our UHF path. And then we also have a path coming down here through this diode. That's our VHF path. That also goes through this diode then and comes up to this transistor, which is our driver. Okay, and then from the driver we go through another set of switched filters here, two different paths. And then that signal then gets applied to this guy, which is the RF output driver. Okay, that output then comes up over here. And let's kind of scoot down here, and goes into basically this set of filters here, down through this path down here, and this path across the top, that ultimately wind up going out to the antenna over here. And there's a couple more switching devices in place here. There's a couple of PIN diodes here. There's a couple of other diodes that are across through these various paths. Some of these diodes that you see in here are actually power sensing diodes that are used for the power control loop. Some of these are in the signal path that are actually turning on and off and allowing RF signals to pass through to the antenna. Some of these switching diodes are also used to switch the antenna between the transmit and receive paths. So these are the places we're going to be looking inside the device. I guess it also helps. I printed out the page that has the layout for the circuit board inside the transceiver. It makes it easier for us to identify which components are which. Inside the device, there aren't that many designations. A lot of the very small components don't have silkscreen designations of which device is which. So it really helps to have the circuit board layout, so we can kind of look at it and see which device is which in this filter path right after the pre-driver, as well as between the driver and the PA, and then in the output filter as well. So we use that. It's very helpful to have that available to you when you're digging in and seeing what's going on inside the transceiver. So let's start off by taking a look at the signals going into the pre-driver on VHF to see that the signal is indeed making it to the pre-driver transistor. And if it is, then we know that the VCOs and everything are okay, and we just need to keep moving forward through the PA. So the first thing we'll take a look at is this pre-driver. Let's just look at the collector, actually the drain of the pre-driver transistor here. So we should be able to see a signal there if the VHF signal is making it all the way through here and being amplified by that. So that pre-driver transistor inside the device here is this little guy right there. This is that SOT89 transistor right here. The collector is that node right there. So we'll take the probe. You'll notice I've got a very short little ground lead on here, minimize the ground inductance for our measurement. I'm going to just stick the probe on this ground screw. It's a nice convenient place, and we'll probe that collector very carefully here. Oops. There we go. So I'm probing on that collector. I'll key the radio. You can see I've got transmit indicator there. I've got no RF output. If I look on the scope, I do have a signal there. So that's good news. So it's good in terms of it tells us which direction we can go. Since we know the signal is making it to the pre-driver, we know that everything up to that point through the VCO and everything else is working okay. So now I know I've got a signal at the pre-driver output. So now what we need to do is let's take a look at the driver output, the one that's going to the RFPA. So that's this device right here. The output is essentially this long connection over on the side over here. So let's go take a look at that. So from the layout we can see from the pre-driver, we looked at the collector here, we're going to go through this switch set of filters to the driver transistor. The output of that we can also see goes to a pair of inductors here, so that's going to be a convenient place for us to probe inside the device. So that's these two sets of inductors, essentially this inductor here, that common set of nodes there, right there we can probe. So I'll do the same thing. I'm going to stick my ground lead on the nearest ground screw there and stick the probe down on that circuit board land. And when we key up, take a look at the scope, I've got a signal there as well. So again, a little bit more good news. We know that we're going through that first set of switched filters and the pre-driver. So looking back at the schematic, that says we're going through this set of filters okay, through these switching diodes okay, and up to this driver transistor. We're just looking at its output right here. So now the next thing is to take a look at over here at the driver. Let's go take a look at the driver. In fact, let's just go for broke and look at the driver output. Okay, see if it's there. If it's there, then we know that this set of switched filters and all the switching diodes associated with that are all working as well. So let's take a look at that. Well, from the schematic, and kind of somewhat obvious from the layout, that the output of this RFPA is this big fat node right in here. So let's take a look at that. So that's this big node right here. So I'll go here. I'm going to change the scale on the scope here from channel 1. We're probably likely to have a larger signal there. And so I'm going to grab ground right over here and just probe anywhere on that connection. And when I key the microphone now, take a look, I actually do have an RF signal there as well. Okay, so I know that I'm getting right through the PA. So that's good news. So all of that is okay. So I've got a 2-meter signal, even available there. So the problem really just has to be in this part of the circuitry. That's all that exists now between the driver and the output, the antenna, which is connected right up here. So we should be able to kind of ferret that out pretty easily. Okay, so looking at the schematic, this is our final output transistor here. Its output is coming up, and as we talked about earlier, it's going through this set of filters. There's a VHF path, which is down through here, and a UHF path, which is up through here. And the way I could tell which one is VHF and UHF is if we look at some of the switching diodes that are in the RF path, like here, these PIN diodes are here. So in order for those pin diodes to turn on, they'd have to get forward biased. So we can usually follow a bias line, and usually that's going to be isolated by an inductor So there's an inductor right here, so that's what's kind of isolating that. And if we follow that line down, we can see a couple of resistors. If we follow it all the way over and around, I'm not going to go all the way scrolling through the schematic. You trust me that that's actually the VHF transmit line. So when VHF transmits on, we turn that node up, we bring a positive bias onto that, that turns these pin diodes on, and would let the RF signal pass through. So I know that that's the VHF path. And similarly, there's a UHF transmit line that we could look at that would bias up the diodes that are in that path. So, so I know this is the VHF path here. Now, these are all passive devices here. I don't expect any problems. Certainly with the inductors, they're just wires. There's a problem with a cap. But, experience kind of tells you that usually semiconductors that are in a high power path are the most vulnerable to problems and things like that. So the first thing I really would suspect are these PIN diodes right here. So let's first just verify that the signal is making it from the PA transistor through the filter up to the input of those diodes. So let's take a look at that with the scope. Okay, so looking at the layout, those two diodes are these two diodes right here. There's little cubes. It's those two diodes right there. They're both in parallel. We saw that on the schematic. So we've got anode and cathode. So the anode is essentially the input side. That's the side that's getting biased up through these resistors and the inductor when we turn them on. So we want to go take a look right at the anodes of those two pin diodes. So inside the transceiver, that's these two little white cubes here and here. So the anodes are this connection and this connection right there. So they're both in common, so I just had to connect to one of them. So again, I'll connect up ground to the screw here, lay my probe up against the anode there, and key the microphone and look at the scope, and yeah, lo and behold, we have a signal there. So there's our 2 meter transmitted signal. You'll notice I'm on 20 volts per division. So I've got nearly, so over 80, almost 100 volts peak to peak right there. So that certainly tells me I've got a nice healthy 2 meter transmitted signal right here. So let's take a look at the output, the other side of those switching diodes. Okay, so I'll probe over here. Okay, and now key the microphone. And if I look, I don't see anything. Okay, unkey and key, I can see a small little bias change when I key, but no RF signal at all. So now that tells me that these diodes are likely the problem, that they're not getting biased on. They might have opened up. We'll make a couple of more measurements to see if that's what the problem is, and go from there. Okay, so before we go condemn these two pin diodes here, let's be sure that the circuitry is trying to turn those diodes on. So this line here I mentioned before is the transmit VHF line. It's going to put a positive bias on this line when we transmit in VHF mode, basically to send a current down, limited by these resistors, down through the inductor, through the diodes there, and then down to ground. That will turn those diodes on, enabling that path to pass RF. So we can probe the voltage at these resistors to see if that voltage is present. So again, transmitter's on, or the transceiver's on. Let's these two are those big 33 ohm 1 watt resistors. This is the first one in the chain. If we probe there and take a look at the meter, and I key the microphone now, yep, so we've got 8.92 volts there. So that's working fine. Let's look at the other end of those resistors, the other side. That's the side now between the resistors and the inductor, which leads to the diode, and I'll key up. Okay, so I've got a voltage there as well. Now it looks like it was pretty much the same voltage, which tells me there's no drop across these 33 ohm resistors. So there's suspicion number one, that there's no current flowing between those. So so I think we can conclude that certainly the path going through there is open. Most likely the diodes themselves are open. But let's take a quick look at what else is in that path and take a look at the diodes. Okay, so I've turned the transceiver off, and first thing we'll do is let's verify what these diodes should look like. I've switched to my little tweezer probes. I've put the meter in a diode measurement mode, which will show me the forward voltage of diodes. So if we forward bias them through my little tweezer connections here. And we also know that there are a couple of other similar pin diodes in like the UHF path, for example. So what we'll do is we'll make some measurements on those as well as these to be sure that we're getting similar results. And also these other two diodes here are in series with these when they're turned on. So let's verify those first. And they're in parallel, so I just really need to kind of probe across one of them, and I would kind of do that this way here, anode and cathode. So those two diodes are right here and right here. So the easier one for me to grab is this guy right here. And if I probe that and take a look at the meter, I got about 0.7 volts. So that diode is indeed working. So I know I've got a path from the cathode of those pin diodes down. And just as a point of reference, let's take a look at some of these other similar pin diodes that I've got in the transceiver. There's one here, there's another one here. So let's take a look at this one here, since I can very clearly see that that's the cathode end. If I probe that one, I can see I've got about 560 millivolts or so. So that works, but you also have to be careful when you do this in circuit. There might be some other path around the diode, so let's turn the leads around, and if there's no leakage path around that, if I squeeze it here, it should show open circuit, and it does. So I kind of verified that, yeah, I can properly measure that diode. Let's look at this one here, okay, and I squeeze that guy, again, about that same 560 millivolts. Alright, and again, let's turn that around, and if I probe it again, that's open circuit. So there's two diodes that are in the UHF path, and they're working. So here's the ones in the VHF path. Let's take a look at those. So this is anode and cathode, so let's squeeze them this way. These are in parallel, so it doesn't matter which one I look at, and that's open circuit. And then just to be sure, let's turn the leads around just to be sure I didn't have things backwards. I didn't, but let's do that anyway. Open circuit again. So we've kind of verified in a couple of different ways that these diodes, these are pin switching diodes, are likely the problem. Looks like they've opened up. No current is flowing through the bias resistors when we go to turn those on. So that indicates that they're open, and certainly probing them and looking for the diode voltage indicates that they're open as well. So the strong likelihood is that these two diodes have opened up on us, and that's the problem. So I don't have any of those here, so what we're going to have to do is go take a look at the part numbers for those, order a couple up and get them here, and then continue the video here, hopefully showing replacing these diodes and effecting a repair. So the next segment here will be after those diodes have come in.